Hello folks, and welcome to the channel, or welcome back to the channel. And in this video we're going to continue to work on the TVR 3000M, and more specifically part number 2 of the DGAS 38 carburetor. And meanwhile the carburetor has been completely cleaned, as you can see, and ready to be reassembled, and this is what we're going to do in this video. And we're also going to talk about each and every individual circuit, and we're going to explain on how all these circuits are working depending on the condition on the engine. If you're running idle, if you're running on acceleration, if you're running on cruising, if we're having cold start. Now carburetors, they all work on the same principle, so it is important to understand the main principle of a carburetor, and that is the Venturi effect. And the Venturi effect is nothing special, and those of you that know this already, you can skip this little part here, but it might be interesting to some others. The Venturi effect is the following. If you blow an airflow over a cavity, and that cavity happens to be the top of a tube, and that tube is submerged in some liquid, then that airflow over the top of that cavity will generate a depression or a vacuum, and as a result of that, the liquid inside the tube will be sucked up and be mixed actually with the airflow, and that is exactly what is happening in a carburetor. So let me give you a little practical demonstration on how the principal Venturi effect is working, and then we're going to start really talking about the actual carburetor itself. Here's a plastic cup of water with a tube inside. So I'm going to blow air on top of this opening here, the cavity, and then you'll see that it will actually suck out water out of the cup and it will mix with the air on the top. So hopefully I can get this. I'm going to keep my hand on it so it doesn't blow away. And what you just saw is the Venturi effect, the same thing that happens in a carburetor. So the water is the fuel, and the little tube that we were using is our Venturi. And the airflow, well, that is the vacuum that is created, or the airflow that is created by the pistons moving down and sucking in air. There are two families of carburetors, one with a fixed Venturi, like the Weber DGAS 38, and those that have a variable Venturi, like the SU carburetors that you see over here. Now when we talk about the fixed Venturi, this is the kind of tube we're looking at. Now this comes out of a DCOE carburetor, but in the DGAS 38 that's fixed, and remember that's a 27 inside. So the opening or the barrel through the carburetor is always the same. It doesn't get more narrow or wider. So that's what we call this a fixed Venturi. On an SU carburetor, on the other hand, you see inside that we have this piston, and this piston can actually move up or come down, and that is varying the Venturi opening. So that's the difference. So we will now focus on the DGAS 38. So we are back in the clean room of the workshop, and that's where I'm doing carburetor work, because working on a carburetor is a bit like doing surgery. You might remember from part 1 that we took everything apart, we laid it all out nicely so we can find our way back when we put it back together. And now it's the time to reassemble the carburetor. The first thing we're going to do now is to look at the idle circuit. Now the idle circuit is the circuit that provides the fuel to the engine while the engine is running on idle. So there's no load, you're running on a low RPM. Let me show you on the board, first of all, how that circuit is working, and then we're going to install it actually on the carburetor itself and look at all the different elements that make up that circuit. And you might remember from the previous video that we have established the standard baseline, and this is the fitting of all the jets and the emulsion tubes and so on when the car left the production belt. That is different for different types of cars. You know, the DGAS is fitted on the Ford SX V6, but it's also fitted inside different cars. It's fitted in the Ford Capri, the Ford Taunus, but also on the TVR and probably a couple of other cars, and therefore the jetting might be a little bit different. But the jetting that you see right here, or the baseline, is typically what would come out of the production plant of a TVR as far as I know it. And it's a very good starting point to start configuring your carburetor. Now, of course, if you have modified your engine and you have a fast cam, or you have a modified exhaust or intake manifold, or you're having a modified cylinders or modified pistons, then obviously this is not going to work optimum for you. You can get far more power out of your car by then adjusting, in fact, tuning your carburetor. But this should be your starting point. Use the standard baseline because this is guaranteed to work properly or almost properly on your car. And when I say properly, I mean it's going to work fine, it's going to run, but of course you may not have the acceleration you expect, you may not have all the horsepower that you would like to get out of it, but it will give you the very basic stated horsepower that your engine will develop or your car will develop. So, with any further ado, now let's start looking at the idle circuit. What I have on the board is a representation of the idle circuit inside the carburetor. On the top we have the air filter, on the bottom we've got our intake manifold, and this is actually the barrel through the carburetor. And on the bottom we have our gas throttle or the butterfly. Now when the engine is running on idle, the butterfly is typically closed, so we can't suck air in through the main barrel. So we need to have a circuitry that will maintain this idle running of the engine. And this is what we call the idle circuit. Now the idle circuit, I have shown it in red here. If you follow the red marked line, it's a channel that goes all the way to the top, and then it has a side connection back to the fuel well where the float is in. So if the engine is running on idle, we will have fuel to a certain level inside the fuel well or the float chamber, right? So this is the fuel here, this is all filled up, and automatically through the main jet in the bottom we'll feed the fuel up to this level here in this channel. So we'll have fuel sitting there. Now because the engine is running, we are having air being sucked in, but the throttle is closed. So we're going to start sucking in air this way through a small opening which is just below the throttle, and I'll show you that in a few seconds on the real carburetor. That means that now we're going to start sucking in fuel like so and down and into the carburetor. Now we can't use pure fuel, so we need to have something which we call the idle jet, and here is the idle jet. The jet is fitted right here in this channel. On the top it's going to take in air. From the side, it's going to take in fuel from the fuel well. That will mix inside this little idle jet, and it's a little tube with two connectors on, two holes actually. I shouldn't say two connectors, but two holes on it. One little hole where the fuel comes in, and another hole where the air is coming through. And remember, this is a small Venturi effect again. And then this mixture will be sucked down, but then it hits the idle mixture screw. Now the idle mixture screw is the one that's on the bottom of the carburetor. That's the one you will adjust for the proper amount of mixture to come in. So as you can see now, we're going to have mixture coming in here, and then it goes inside the carburetor. However, the idle mixture screw is not determining the air-fuel ratio of that mixture. That is determined by the idle jet, and the idle jet comes in different sizes. The idle mixture screw is just going to adjust the amount of mixture we get into the actually cylinders. It's important to know that if you're going to adjust the screw and you need to make it more than 3 turns out, that means that your mixture is too lean. It means actually that the idle jet, the opening where the fuel comes in, is too narrow. You need to get another jet. You have to open up that hole right here so we can get more fuel in. On the other hand, if you need to turn down the screw to less than 1 turn, then normally it means your mixture is too rich. Then the idle jet has to be reduced. So the opening right here on the idle jet where the fuel comes in has to become smaller. So keep that in mind if you're going to do this. So the ideal setting from a rebuild is that fit in the idle jet, make sure that all the channels are free, and then set the idle mixture screw fully in, don't force it, and then turn it back 1.5 turn. That should be a good starting point. And remember, once you have it on the car and you adjust your carbon dioxide measurement, because you have to do this for the MOT, then you will need to adjust the idle mixture screw. So anything less than 1 turn or more than 3 turns out is really an issue, and you should adjust the idle jet. So let me show you that now on the actual carburetor, where all this is. When the engine runs idle, the butterflies are closed, so no air can get through. And on the side here, you have that little hole. You see that hole in the side? You have it on both sides, and that's where the mixture comes in for the idle running. So the idle mixture screw fits on the side of the carburetor, and then you can see the channels which are going up like so, and on the top of it we are fitting actually the idle jet, and this is the idle jet. I haven't taken it apart yet, but if you look very closely you will see an opening in the front. That's where the fuel is coming in, and you will see an opening, if I can turn it around, and hopefully you can see it. Wow. And there is an opening on the side. That's where the air is coming in. So this is kind of a miniature Venturi. And this idle jet, well, that fits all the way on the top, and then we need to screw that in. And of course we'll have to use a seal for that, and this is the little seal that goes with it. And this is the combined screw and idle jet, and you can take this apart. Let me just do that. And here we go. You just need to pull it out, and this is how it fits together. And on the side you have a little hole, that's the air hole, and in the front you have actually another small hole right there, which is the hole which the fuel is being sucked in. So in other words, we have what we call a very, very small Venturi system. So let us assemble the idle circuit for both barrels. For that I'm going to use the revision kit, and I have my old idle adjustment screws, the old springs and the old washers or the seals that go with it, and I also have my the idle jets. I clean them up. You make sure that all the holes are free. They are still in a good condition, so I'm not going to change them, and they match the baseline. And then of course we have the screws that we cleaned up. One of the things is, if you're going to get a revision kit, you might want to check things out, because it's not always that great. This specific idle adjustment screw here is not really well machined. I don't like it. There's a lot of edges on it and rims. So the old ones that I have, they are looking a lot better. So check it out if they are straight, like so. The pin, especially the pin. If there's no damage or wear and tear on them, and they look better than your revision kit, well, then use your original Weber parts, because the revision kit doesn't look to be like an original Weber, although they sold it like one. But I'm not happy with this quality here. That needle here doesn't look proper compared to that one. So those, well, I'm going to put them aside. I'm not going to use them. But I will use the new springs on them, so let's do that already, and that's one. And of course I'm going to reuse my old jets. They were still pretty much intact. There's nothing wrong with them, and it's my baseline, so let me put those together, and then we will install them into the carb. All right. For that we need to install a new seal, and here are the little seals that we were talking about before. So we'll have to put that seal in there first, and that might be a little bit tough to show you that, but I might actually try to fit it first on these idle jets. That might be a bit easier to put it in, and this is how we should do it, I guess. And now that's going to seal it up nicely. And let me push it all the way to the end, because that's where they have to be. All right, so that's one, and now I'm going to put the second new seal up. And I think it's this one right here, and the other ones are the two old ones. They're still reasonably well preserved after all these years, so maybe somebody has rebuilt it before, who knows. Let me put these up. All right, that's good. So now I can install this into the openings, and then screw it down, and then we should have the idle jet installed. You don't need to over torque it. We also do the other side, which is a little bit higher up, over here. And let's install that as well, and then we should be good to go. Here we go. Don't over tighten. And then we can install the idle mixture adjustment screws. They go here on the side. They don't typically have a seal. Oops. So let me just move that around a bit, because it's a bit handier for me to do it like this. Now we can turn that in. So I'm going to turn those all the way in, and then I'm going to turn it back a turn and a half. So if you put these idle screws in, look at the inside, and turn it until you see the pin coming through, and until, in fact, it's really blocking off that hole. That's what you want to do. And then turn it back a turn and a half. So let's do that and see. So this is like one turn, turn and a half. Let me do the same on the other side. So we finished the idle circuit. I'm going to put the parts that I recovered from the old setup into my bag here, because some of them are still good. I can always use them as spares, and remember that you always need to check the quality of the parts you get, even on a rebuild kit. So I didn't like these needles, so my old ones are back because they're still pretty much intact. And it's not because you have a revision kit that the parts are so much better than the original kits, because often it's an aftermarket revision kit and you don't have control on that. You can't see it on the website. So I'm certainly going to complain about this to the web store that sold me that, the poor quality on this. Anyhow, some of its stuff is good quality, some of them is less. So now our car is running on idle, and the idle circuit is working fine, as we have just cleaned it up and we have it installed, and we adjusted the carbon dioxide to the MOT norms, and it's always better to make it a little bit more rich than lean, but we'll do that later. So now we need to get that engine from a idle condition to a running condition, and that's a bit of a problem because the gas throttle is still closed. So we need to get this main circuit working. And the main circuit is actually the flow coming through the barrel and out of the carburetor. And actually it should activate the secondary venturis, which are the ones that I have here. Now, that can only work if you have sufficient airflow, air volume, and air velocity. And we don't have that yet because the butterflies are still closed. And that's why we have a circuit called the progression circuit. And the progression circuit is nothing really special. And let me show you on the board what the progression circuit is, and then we have a look on the carburetor where that is. And let's assume that our engine is now running at idle. And now the gas throttle is obviously closed, and as we explained before, we're getting mixture in through the idle circuit. However, we want to accelerate, we want to get the engine to a running condition, we want the engine to progress. And that's why we have a progress circuit. And the progress circuit is nothing more than a couple of additional holes past the butterfly that are coming into the same fuel channel as the idle channel. They have no restriction, of course, by the idle mixture screw. In fact, there are 3 holes. I'm only showing 2 of them, but there are 3 holes and they're kind of lined up in a triangle. So whenever we now want to get the car moving or the engine moving from idle to running, what do? Well, we depress the gas throttle, and the gas throttle will move this up like this, like so. That would be the new position. And now what we see is that the first progression hole is opened up. We still have the idle, but we now have the first progression hole, which is uncovered. And as a result, because we are sucking in air, we're now going to get in fuel through the idle system, but we're still getting fuel now in through the first progression hole. So now the engine is getting a bit more mixture, it's going to develop more power, so it's able to rev up. And of course we will continue to push the gas throttle in the next position, which is probably a little bit exaggerated, but it's going to disclose now the second progression hole and then the third one. So while we're depressing the gas pedal, the butterfly opens up more and more, disclosing the progression hole, so we get more mixture and mixture in. So right now we are running on idle and we are getting mixture through the idle circuit. But as soon as we open up the throttle a bit, you can see that we are starting to expose additional holes there. In fact, there are 3 holes, right? Those are the 3 progression holes. If you go into adjust your idle mixture screw, then you have to make sure that the progression holes are not exposed. So if you have your RPM screw, which is sitting here on the side, way too far in, look at the butterflies, because that will force them to open up or uncover one of those progression holes. See that? Now, if you were in that position, you can see now the progression hole is open. Now you're going to do a complete wrong adjustment on your idle running. So make sure that before you put the carb on the car, that you have adjusted the RPM screw so that in a way that the first progression hole is totally closed. It is important that both butterflies are exposing the progression holes at the same time, so the left and the right. And that's why you might need to adjust the screw here. So you can undo this screw, and then you can adjust one of the butterflies by sliding this up or down. And that will allow you to align up both butterflies to the exact position. I have just done that, but I'm going to show it to you one more time. So you can undo the screw here, and now you'll see you can move this guy around a bit. See that? See that little movement you can do here, right? This, and that's where you need to do the fine adjustment to align the exact moment when both progression holes on both sides are opening up at the same time. If you don't do this, then you're going to have a problem, because you're not going to progress equally on both cylinders. So let me try this up and see how that is on the holes, progression holes. That one is slightly open, that one is not open. So let me open up that and see. Yeah, it's not aligned as such now, so I need to readjust it. It's a bit of fiddling, and it's a bit of difficult in front of the camera, but this can be done. So let me just take care of that for a minute. And all right, so I think it's over here somewhere, because I need to get it a bit more closed. This looks about right to me. All right, so let's check it. Progression hole is closed there, and progression hole is closed. So let me open it up a bit and see if I expose both at the same time. And that looks more or less good. So this is a good setting. So keep that in mind, that you need to do that adjustment. So now that we have the engine past the progression state, the gas throttle is more open. So now it's time to activate the main circuit. And the main circuit has a couple of elements, and I'm going to walk through the elements first, and then we explain how it works. Inside the barrel, we have the secondary venturi. And that's the one that will actually spit out the mixture of fuel, and then it will mix it with air, and then we get a proper mixture down into the carburetor. So that's what has to happen. We need to have that fuel mixture arriving there. Now, when I say a fuel mixture, I actually refer to an emulsion. And an emulsion is a mixture of two elements, right? It could be like fuel and air, whereby you can still see the different parts. Maybe they're all different bubbles, air bubbles and fuel bubbles. Now that mixture is created, the emulsion is created inside the emulsion tube. And this is the emulsion tube right here, this part with all these little holes. And on the top of the emulsion tube, we have what we call an air correction jet. It has a certain opening, and it allows air to come in from the top. On the bottom, the emulsion tube is filled with fuel. And the fuel is coming through the main jet, which is sitting in the flow chamber. So if fuel is in the flow chamber, then the emulsion tube will fill up with fuel. This will be all fuel. And now that the engine is running, of course, we have an airflow coming through the whole system. It's going to create a depression on the secondary venturi, and that will actually suck in mixture through the holes that we have in the emulsion tube. So this emulsion will be sucked in into the secondary venturi, and there the real venturi effect will happen. The air that is passing by with a certain amount of velocity will pick up this emulsion and will make it into a very small mist of air and fuel with hopefully the proper air-to-fuel mixture. So there's a couple of elements now that come into play. From the bottom of the fuel well, we have to pass through the main jet. Now the main jet will have a certain opening, this one right here, and we may have to change that. It could be that the volume of fuel coming through it when we are running on cruising speed isn't enough, so the level would be too low in the emulsion tube. The level could still be high in the flow chamber, but because we can't fill this up too fast enough, because the opening is too small, we may have to change the jet. So it's important that the jet is sized properly. Also the emulsion tube, it's a tube that comes in different forms and formats. Now typically it's an F50, and it makes a difference where these holes are in the tube. And then on the top of it we got the air correction jet. So air, of course, will also come in from the top. We have fuel coming in from the bottom. It will be all mixed in the emulsion tube, and then it will escape through these holes on the side and then fill up the secondary venturi. So now you can also see that the float level becomes very important, because the float level in the emulsion tube will be the same as in the float chamber. It's going to be exactly the same because it's going to fill it up through the main jet. Of course, that assumes that the main jet is of the right size. So there's a lot of things to consider here. Now, once all this is set up properly, then we're going to get the proper mixture into the engine, and we are running actually at cruising speed, and that is actually now the main purpose of the main circuit. Now, there's a couple of things we need to add to this. Of course, we are not always going to cruise along. I mean, it's not always downhill or flat. Sometimes we go a bit uphill. So it may be that we need some additional enrichment on top of the normal secondary venturi activity, and that's why you find on the top of the carburetor two little tubes, one tube per barrel, which we call the enrichment tube. And that tube is a very fine tube which is going straight into the fuel chamber, and there is a calibrated piece of brass in the middle that allows only a certain amount through. So basically we're going to get some mixture coming out here as well. So that's what we call the enrichment tube. Not always, but for sure, if we have more load on the car or we're going a little bit uphill, then this will actually aid into providing more fuel, and it will come to the help actually of the secondary venturi. Now let me give you a little explanation now on the emulsion tube itself, because the name emulsion may throw you off. If you remember your high school days, then you remember that emulsion was a mixture of two elements whereby you could still see the two elements in it. What I've done for you is a glass of water, and on top of it I poured some olive oil on it. And now you can see the two are nicely separated. So if your engine is not running, the glass would be your emulsion tube. You would actually see the fuel coming in here, and then air is sitting on the top, and the air would be the oil. But once the engine starts running, we're starting to suck in air, of course, through that secondary venturi. And then this whole mixture will mix up. So now let me mix that. And now you will see that we get an emulsion, right? Of course, it disappears after a while, but if I keep on running in it, you will see that we mix the oil and the water in all very small bubbles. And that's what we call an emulsion. How much air or how much fuel we will mix, that depends on the jets, the air correction jet and the main jet. So this is a bit of a close-up of the emulsion tube, and here you have that brass tube, and it has a couple of holes in it, and these holes can be in different places. And the tube that typically is on the DGAS 38 or the standard tube is an F50. You can get other tubes, and the difference will be the holes are in different places, and they may be bigger or larger. Now on the top of the tube we have the air correction jet, which has a certain size, and on the bottom, of course, we have the main jet, which is in the fuel chamber where the float is. And as I said before, the float level inside the fuel chamber is very important. So let's say this is the float level. So then fuel will, of course, come through the main jet, and it will fill up the emulsion tube to an equal level. Now, as soon as the engine starts to run, and we are running on the main circuit, obviously, we're going to suck air through the correction hole, and we're going to, of course, suck in fuel through the main jet. Now, the way we suck this out is through these little holes here, because all these little holes are actually going towards the secondary venturi. And that's the one that generates the vacuum. So we are sucking that out. So what you get is fuel and air that comes together. Some of it is pure air on the holes. Other holes are actually almost pure fuel. But you're going to get, when all this comes together, you're getting this big mixture of air and fuel, this emulsion, as I just shown you on the glass. And that's what we're going to get into the secondary venturi. Now, what is important here is that the fuel level in the fuel chamber has to be correct. That's why you need to do an absolute correct adjustment of your float, because that will determine how high the fuel is in the fuel chamber. You can immediately see if the fuel level is too high in the float chamber because you have not adjusted the float correctly, that the fuel level will raise in the emulsion tube. And as a consequence, you're going to get an emulsion which is far more rich, so you're going to run real rich. On the other hand, if the fuel level in the fuel chamber is too low, like so, then the emulsion tube will be partially filled up, and we're going to have a far more lean emulsion go into the secondary venturi. So neither one is good. So you have to have that right. So if you have the fuel chamber set to the right level, then you will have a proper level inside the emulsion tube. Now it can be, while you're running the engine, that you're going to kind of lower the level of fuel inside the emulsion tube, mainly because your main jet may not be large enough. So the main jet really will have only an effect on the amount of fuel level that you can retain, so the volume going through the emulsion tube. The other thing you might want to do is to adjust the air correction jet. Maybe you want to run a little bit more lean, so then you're going to get a wider opening here on the top of the air correction jet. Maybe you might want to run a little bit more rich, then you're going to reduce basically the opening here on the air correction jet. And maybe you want to have a complete different behavior, and you might want to look for another emulsion tube, because they come in different types where the holes are different, so you're going to have a different behavior. So I hope that I could explain the emulsion tube concept to you. So now let's see where that main circuitry is on the carburetor, and then we're going to install it all. The parts that make up the main circuitry are the emulsion tubes. You can see them, they are laying right here, and you can see the holes on the side. These are F50 tubes. On the top we mount the air correction jets, those are the two. And then on the bottom we have the main jets, and it's kind of funny that they call this a main jet, because you would expect a big jet. It's not, it's a small jet. And then finally on the top, which is fitting into the barrel, we have the secondary venturis, which are a size 4. And the mixture or the emulsion is coming in right in this hole, and it gets sucked inside and then into the actually a carburetor, sucked out through the hole in the bottom here. If you look inside, you will actually see a hole there, and that's where the emulsion comes out and mixes now with the air which has been sucked in by the engine. So let's install this on the carburetor. Let's install the secondary venturis, and remember the hole always fits towards the centerpiece. There we go. Not very hard, they just slide in. So now we'll install the emulsion tubes. They just slide in these holes. There's nothing special to it. Just drop them in. And on the top we'll install the air correction jets. And again, don't over tighten, and there are no seals on this. And now we'll install the main jets, and the main jet is installed right there in those two holes. Now the little hole that you see on the side here, this is actually used for the enrichment tubes. And these are the enrichment tubes that are fed through the holes at the bottom of the fuel chamber. And they only come into play under a normal running condition, when you need just that extra little bit of power, so you're sucking a little bit more vacuum, then you will have extra mixture coming out here. And in fact, these tubes are calibrated inside, and it's probably hard to see, but let me try to show you anyway. These are the calibration parts for those tubes, so they are very fixed dimensions. This might be a little bit difficult with the camera in the way or my hand in the way, so let's see if we can get it in. There we go. Yeah,